Hey everyone, welcome back. Today we're going to talk about compound inequalities. A compound inequality is when you have two inequalities and you join them together with the words and or. You can also have a three-part inequality. This represents an inequality using the word and it just combines those two inequalities into one, but with three parts. I'll show you some of those. And then we need to talk about interval notation. Interval notation is the notation you use to write sets of real numbers rather than using a number line or an inequality. So if you have strict inequalities, like less than or greater than, you would use interval notation that uses parentheses. Parentheses represent these strict inequalities. If you have a weak inequality, that's a less than or equal to, or a greater than or equal to, those need brackets. The brackets represent the equal to part and say that that number is a possible answer, where the parentheses with the strict inequality are saying that that number isn't a possible answer. Let's look at a couple of examples. So example 1, we have a three-part inequality. And we're asked to write the inequality in interval notation. This is a three-part inequality, so it's an and. We know it's a three-part because it has three parts, three terms, and separated with two inequality symbols. So if we were to put this on a number line, pictures really help me. And we put the numbers on that number line. Our numbers are 5 and 8 for this inequality. We know that our value of x falls in between 5 and 8. So it could be any number in here. Well, it's saying that x is greater than 5. And since that's a strict inequality, we would put parentheses there. And then x is less than or equal to 8 is a weak inequality because of that equal. So we would put a bracket at 8. This is how we would represent that three-part inequality on a number line. And if you can get your inequalities onto a number line, that number line spits out your interval notation. So we know that our numbers go from 5 to 8. And at 5, we have a parenthesis. And at 8, we have a bracket. So from the number line, we are able to easily write that interval notation. Now, look at example 2. Again, if we put this on a number line, and the numbers we need are 3 and 6. So I like to use two different colors when I'm graphing two different inequalities. So the first one I'll use blue. And here it's saying x is greater than or equal to 6. So all of the numbers greater than 6 are to the right of 6. And to be equal to 6, we would need a bracket. So that would represent that first inequality, x greater than or equal to 6. The second, x is greater than 3. So every number greater than 3 is everything to the right of 3. And because it's a strict inequality, we have a parenthesis there. Now, an or inequality, you're looking for the solution that satisfies either of the equations. So it can satisfy either the blue inequality or the red inequality. So our solution here, we go from 3 with a parenthesis all the way to infinity. And since infinity can never be achieved, you can never get there, infinity is always represented with a parenthesis. So our interval notation for this or inequality is the interval 3 to infinity. Let's look at some other compound inequalities. So here we need to solve the compound inequality, and then we want to graph the solution set on a number line. So again, I'm going to use two different colors, a blue and a red. So let's solve the first one with blue. So our goal is to isolate x. So to do that, we're going to need to add 4 to both sides. And then this will result in x is greater than or equal to 1. Okay, now let's solve the second inequality. We're going to add 4 again to both sides. And here we get x is less than or equal to 7. So now we have the compound inequality, x is greater than or equal to 1, or x is less than or equal to 7. So if I draw my number line, and I put my numbers on there, 1's here on the left and 7 is here on the right, now I can use the corresponding colors to shade each inequality. So my blue inequality, x is greater than or equal to 1. The nice thing about inequality is if you have your variable on the left and then the inequality and then the number, the inequality sign points the direction you need to shade. So this one's saying we're going to shade to the right because it's pointing to the right of 1. So our blue inequality goes to the right. And because it's a weak inequality, greater than or equal to, we need a bracket there at the 1. Now the second inequality, we're going to be at 7, and the inequality is pointing left, so we're shading to the left. And again, this is a weak inequality, so our bracket is here at the 7. So now we need to determine what our solution is. So in OR inequality, remember it's saying that we're looking for an answer to the blue inequality or the red inequality. So we want to translate this onto a number line as our answer. And again, if we have our 1 and our 7. So what is a solution for the blue inequality? Well, everything here from 1 to the right. And a solution for the red inequality was everything to the left of 7. So because this is an OR inequality, we ended up shading the whole number line. So our answer, if we needed interval notation, would be negative infinity through infinity. Any number on the number line satisfies one of the inequalities or the other inequality. Let's look at another example of an OR inequality. So the first inequality, negative x is less than 1. To isolate a positive x, we're going to divide by a negative 1. So that gives us x on the left and negative 1 on the right. Now remember, if you ever multiply or divide by a negative, you have to flip that inequality. And now let's solve the second. We need to subtract 1 first, and that gives us 5x is less than negative 11. Divide by 5, and we have x is less than negative 11/5. Now I'll draw my number line, and the smallest number we have is negative 11/5, so that'll go on the far left, and the negative 1 is here on the right. Remember, we always go from smallest on the left to largest on the right because it goes from negative infinity to positive infinity. So now let's shade. Our first inequality, x, is greater than negative 1. So it's going to be from negative 1 to the right. And because it's a strict inequality, there's a parenthesis at negative 1. And then our second inequality is x is less than negative 11/5. The inequality is pointing left, so we shade to the left of negative 11/5. And since it's a strict inequality, it's a parenthesis again. Now remember, an or is the solution to either of the equations. So what would our final answer be for this one? Well, the blue is solved with everything to the right of -1, and the red is solved with everything to the left of -11/5. Or in interval notation, that left chunk is -infinity to -11/5, and the right chunk is -1 to infinity. And because we have two pieces and an or inequality, we use the union symbol to say that the solution is this first chunk or the second chunk. So a good hint for an or inequality: an or is anything you shade. So if you draw your number line and you put each inequality on that number line in a different color, the answer is going to be any piece of that number line that you shaded, anything that got colored. Let's go to page 2 and look at some and inequalities. Now, and inequalities, my hint for you, and equals purple. So if you continue to use the red and the blue like I do, you'll see what I mean by an and equals purple. So first, let's solve that first inequality. We need to add 1 to both sides, and we have 3x is greater than or equal to 0. Divide by 3, and we have x is greater than or equal to 0. And I'll change colors to red. I need to add 1/2 to both sides, and I have 2x is greater than 6.5, or 2x is greater than, this is the same as 13/2. And to remove the 2 that's in front of the x, I'm going to multiply by its reciprocal, 1/2. So I get x is greater than 13/4. So I'll draw my number line. The two numbers I have on this number line would be 0 and 13/4. Those are the most important. Now first I'm going to shade for the x is greater than or equal to 0 inequality. So that's everything to the right of 0. And because it's a weak inequality, greater than or equal to, I have a bracket at 0. And then I'm going to look at x is greater than 13/4. So that is everything to the right of 13/4, and it's a strict inequality, so we have a parenthesis here. Okay, we need another number line because we need to transfer our answer for these inequalities to one number line. Remember I told you that and equals purple? Well, an and inequality is saying that the solution has to work for both inequalities. So it needs to satisfy the blue and the red. And what happens when you mix blue and red? You get purple. So our solution is every place on our number line that we have blue and red. So we have to have purple. And blue and red is everywhere from 13/4 to the right. Or if we needed interval notation, it would be a parenthesis at 13/4 all the way through to infinity. Let's look at example 2. So again, we're trying to isolate our x. So let's subtract 1, and we have -7x is less than -49. Now we're going to divide by -7 to get x by itself. So we have x on the left and a positive 7 on the right. And remember, because we divided by a negative, whenever you divide or multiply by a negative, you have to change your inequality symbol. So it becomes x greater than 7. And let's look at the second inequality. We subtract 1 from both sides, and we get 3x is less than or equal to negative 10. Divide both sides by 3 to get x is less than or equal to negative 10 thirds. So now we need our number line, and we need to put our two numbers, 7 and negative 10 thirds, on that number line. So our smallest is negative 10 thirds, and our largest is 7. So we'll start with the first inequality, the blue inequality, and we know that x is greater than 7. So that's everything to the right of 7, and it doesn't include 7, so it is a parenthesis at 7. And then our red inequality is everything to the left of negative 10 thirds, because it's less than. And since it's a weak inequality, less than or equal to, we have a bracket. Now we need one more number line so that we can represent our solution. So an and inequality is anywhere that the red inequality and the blue inequality have a solution in common, or where we see purple, the shading of red and blue together. And where do we see red and blue shaded together? We don't. So there is actually no solution to this compound inequality. So if you needed to shade the number line, you wouldn't. This number line would just stay as a blank number line, and you would write no solution. Let's look at another three-part inequality and how you solve a three-part inequality. So with a three-part inequality, our goal is to isolate our variable in the middle of the two inequalities. So we have an x currently in the middle. So first we need to move this 4. Since it's a positive 4, we're going to subtract it. And when we subtract it from the middle, we have to do the same thing on both sides. That's the trick of a three-part inequality. Every step you're doing 3 times. So on the left we have 3 minus 4, which is negative 1. We keep the less than or equal to. We're left with negative x in the middle, another less than or equal to, and 6 minus 4 is 2. Now we need a positive x in the middle. So we're going to have to divide by negative 1 to make that positive. So we need to divide each side by negative 1. So negative 1 divided by negative 1 becomes a positive 1. Negative x divided by negative 1 becomes a positive x. And 2 divided by negative 1 is a negative 2. And again, divide or multiply by negative, you flip those inequality signs. So it goes from less than or equal to greater than or equal to. So look, our answer is 1 greater than or equal to x greater than or equal to negative 2. So this is saying that x is between 1 and negative 2. But that doesn't make sense because negative 2 is a smaller number. So we need it to be negative 2 on the left and 1 on the right. The easiest way to do this is if you look at negative 2, the small part of the inequality is pointing towards the negative 2. Or if you concentrate just on this right inequality, x is greater than or equal to negative 2. And if we read this part from right to left, because we have to start with x is greater than or equal to negative 2. So now we need to do the same thing on the other side. we need a less than or equal to 1 because x needs to be less than or equal to 1. So here we have solved our three-part inequality. We know that x is between -2 and 1. So now we have to translate that to interval notation. We know it goes from -2 to 1. And then parentheses or brackets. Correct, they're both brackets because they're both less than or equal to's. They're both weak inequalities. How about an application example? So, if the dew point D on the ground is 60 degrees Fahrenheit, then the dew point x miles high is given by d of x equals 60 minus 5.8x. Now, d of x, this is just function notation. It's just another way of naming a function. So this is saying d, the dew function, given x, miles. We need to find the altitudes where dew point ranges from 57.1 degrees Fahrenheit to 51.3 degrees Fahrenheit. So concentrating on that last sentence, we know that our dew point is going to be greater than 51.3 and less than 57.1. And we know the equation for our dew point, so we can substitute that in. So we have 60 minus 5.8x, and that's greater than 51.3 and less than 57.1. So now we just need to isolate x in the middle of this three-part inequality. So first, subtract 60. And remember, you subtract it from the middle. A three-part inequality, you have to do it in all three places. So on the left, 51.3 minus 60 would be -8.7. And the 60s cancel in the middle, and we're left with -5.8x. And 57.1 minus 60 is -2.9. Okay, so the last step, to isolate x, we need to divide by -5.8. So let's do that on both sides too. -8.7 divided by -5.8, the negatives will cancel and we get a positive 1.5. In the middle, the -5.8 simplify to 1 and we're left with just x. And on the far right, -2.9 divided by -5.8 is actually 0.5. Now remember, we divided by negatives, so we're flipping those inequality signs. But look, once again, we have our large number on the left and the small number on the right. We really want to have that small number on the left and that large number on our right. So we can change their sides, and that forces those inequality symbols to change. So what does this mean? X is between 0.5 and 1.5. Well, it means from 0.5 to 1.5 miles, the dew point ranges from 57.1 to 51.3. See, that wasn't too bad. Just slowly start writing out with what you know and then work step by step. Have a question or a problem you want help with? Leave it in the comments and I'll include it in one of my videos. If this video was helpful, subscribe to my channel for more math tutorials. Thanks for watching. See you next time.